This example says use Pascal's triangle to expand a plus b to the fourth power. Now, if you don't know what Pascal's triangle is, it's depicted below. So this thing here is Pascal's triangle, and the outer edges of Pascal's triangle all have entries of the number 1. And the way that you get the other entries, other than the first and the last entry in each row, is by adding the two numbers that come above it. So 2 here is coming from the fact that we are adding 1 plus 1. Similarly, in this row down here, we add 1 plus 4 and we get 5. So in every row of Pascal's triangle, the first number is 1, the last number is 1, and then we get the other numbers by adding the two numbers above it. So how could we use Pascal's triangle to expand a plus b to the fourth power? Well, before we get into that, maybe let's expand a plus b squared, or to the second power, which is the same thing as a plus b times a plus b. Now, you can go about foiling this or using the box method. Either way, when you expand that, it turns into a squared plus 2ab plus b squared. Now, if you'll notice, the coefficients of each of those terms are 1, 2, and 1, and those correspond with this row right here. And that's not a coincidence. So that's how we can use Pascal's triangle to help us expand the power of this binomial, is by using Pascal's triangle, which represents the coefficients of each of these terms. So let's see how that comes into play if we wanted to expand a plus b to the third power. A plus b to the third power is the same thing as a plus b squared times a plus b. And we already expanded a plus b just a moment ago. We said that that was a squared plus 2ab plus b squared. And if I want to multiply that with a plus b, I'm a big fan of using the box method. So I'm going to come down here a bit and I'm going to create my box. On this side, I'm going to put a plus b. Here I'll put a squared, 2ab, and b squared. And if we multiply according to what's on the outside of each of these boxes, here is what we should get. Okay. So I'm going to go ahead and combine like terms now, and one of the other reasons I like the box method is because we can kind of see the pattern of where my like terms are. So there's a pair of like terms, and then here's another pair of like terms. So if I go ahead and do that, that's going to give us a cubed plus 3a squared b plus 3ab squared plus b cubed. Now notice the coefficients of each of these terms. My first coefficient is 1, my next coefficient is 3, my next coefficient is 3, and my last coefficient is 1. Those are exactly these numbers right here in the n equals 3 row of my Pascal's triangle. So that is how we are going to use Pascal's triangle to help us with expanding a plus b to the fourth power. So what is the pattern? Well, we're going to come down here to row n equals 4. There's our coefficients. So from this, I'm going to be able to gather that a plus b to the fourth power is equal to, I'm going to go ahead and write out those coefficients. So I have my 1, my 4, my 6, my 4, and my 1. And the way that I figure out the rest of the information is I look at the first term inside of my binomial, and I want to raise that to the fourth power because our exponent here is 4. So it'll be a to the fourth power times b, which is the other term in my binomial. I'm going to raise that to the 0 power. And in all of these sets here, the exponents should add to whatever exponent we have in the original expression. So I have a to the fourth times b to the 0 power. Notice that 4 plus 0 is 4. In my next term, I'm going to decrease the power by 1 on a, so it'd be a cubed times b, and then on the b, I'm going to increase my exponent by 1. Notice still that if I sum the exponents here, 3 and 1, that will give me 4. So can you continue on the rest of the pattern? The next one would be a squared, b squared. The next one would be a to the first power, b cubed, and then the next one would be a to the 0 power times b to the fourth power. Now we can clean this up a little bit because 1 times anything is itself, and when you raise something like b to the 0 power, that also becomes 1. So if we go through and simplify these, my first term would be a to the fourth power plus 4a cubed b plus 6a squared b squared plus 4a b cubed plus b to the fourth power. So in terms of the original example, if we are expanding a plus b to the fourth power using Pascal's triangle, this thing here is our final answer. And we could absolutely have done this just by foiling like we are used to, or just using the box method. But sometimes this can be a quicker method if our exponent is potentially a higher number.